Hello, this is Anthony Radamonte with Copley Controls. Today I'm going to be showing you a cool CMO example, and basically it logs data over the CAN port to a CAN drive. So first let's look in CME here. I have an MP3, so that's 3 axes, A, B, and C, and I have an address. The first node address for the CAN network is 1, so the CAN node ID is 1 for axis A. For axis B it's 2, and axis C it's 3. So a brief overview. Let's go to, if you go to File or Help, All Documents, and you click on the CANopen Programmer's Manual, you can bring it up here. Here we have a list of the, if you go to page 23, you'll see the CANopen default mapped PDOs. What my CMO example is going to do is edit the default mapping here, and we're going to collect data, and we're going to log it into a list, and then we're going to export that list of data to a CSV file. CSV file is the file format for Excel, so you can do all sorts of cool things with data in Excel, and it's pretty useful. However, just as a note, in Excel there is a limit to how many rows you can have. So I think for our example that'll limit us to collecting a little bit over 1 million points of data. So I'll get back to that later. Here is the default PDO mapping. So you have 8 receive PDOs, RPDOs, and 8 TPDOs, transmit. So what this is saying is it's going back and forth from the master, these PDOs. So you have a CANopen master. In our case, our CANopen master will be CMO, Copley Motion Objects, our software. And it's going to be controlling the slave, which is the drive itself. So here's the receive PDOs. So this is drive centric, which means that the drive is receiving these PDOs. These are commands from the master. So you have control word, target position, go here, do this right now, and then you have these transmit PDOs saying, got it, status word, position actual value, here's my actual torque, here's my actual position. So it's giving you feedback here, giving your inputs, yeah, so you can map, you can change the default mapping of these PDOs. So you have PDOs 1 through 8 and 1 through 8. So this is per axis, we have this configuration. So for my MP3, each axis has this default mapping. So let me now talk about, okay, so we have trigger type. We're going to use sync message to trigger. So every sync message, every sync period will be sending will be triggering these PDOs over the CAN network. Another quick thing is you can download for free online CANview. It's our Copley software that you can access the port. Right now I'm not doing anything, so but you can see all the messages over the CAN port in real time. So if you have a Copley CAN card, you can access that CANview software. So now that we've talked about PDOs and what they are, basically they're cyclic data back and forth from the master. Let's go to the example here. So I'm going to go to the PDO. So here CMO comes with these examples, right? So you get default examples. If you go into the example 9, we have a PDO mapping.cs file, and that shows you how to properly edit the PDO mapping in CMO. Let me show you that, and then also I'm going to also bring up the project that I've been working on that creates the log. So if I can just find that, here it is. Okay. So Visual Studio is what we use for CMO. 2019 is the latest version of CMO that runs on the IDE. So before I get into this example, let's go to the example that comes standard in all CMO. We have the PDO mapping, example 12. So this program demonstrates PDO mapping over CANopen Node. So this example shows you how to edit, transmit, and receive PDOs, and save the mapping to Flash, and talks over to CAN node ID 1. So here we have we have axes CAN node ID 1 and 2. So let's see here. So right away, this creates these two lines are standard in all CMO examples. They create a debug log of all the messages. So if you have an error or a problem, you'd want these two lines, and then you'd run the code until you encounter your problem, and then you can debug. You can look in the log and see all the messages between the drive and the CMO. This is an amplifier object. You create this for the axes that you're talking to. So as many axes as you have, you'd create as many of those objects. So in here you'd say, amp 1 or amp 2, so on and so forth. This is creating a TPDO object, and then you have your arrays that you're going to load your CANopen objects into, and their subindexes, and then your this P map obj you would load. You have to tell the drive how large the data is. So that's what this is going to contain in it, this actual size of the data. Then we have RPO objects, similar, and then you have the actual data here. So similar format, but RPDOs you're commanding to the drive, so you're writing this data to an object. What I'm going to do now, let's go down here. So here again, we're logging all those messages, and we initialize the amplifier object. So the axes, it's axes A, we're initializing there. We initialize the CANopen network object. So we have one CAN network, and then we give it a bit rate. We want 1 megabit per second. That's the fastest bit rate possible. The port name is Copley 0. We also support Kvasser. So if that was the case, then you would write in there it would be Kvasser 0 for the port name. But Copley, we have debugging software that is nice for Copley. Kvasser also has CAN King software, but then we're going to initialize the CAN network here, and then we're here you have ampSettings object. So in here you can set the guard time, so this disables node guarding. You could set the synchPeriod, and then you could use that. That's what we're going to do in our example. And then here as I said, we have to we initialize the TPDOs here. They're only using one TPDO in this example. In my example, I'm going to use 2. And then we have to say, okay, the first entry here, the first object, how large is it going to be? It's going to be 16 bits. And the second one, it's going to be 32 bits long. Each PDO can only contain 64. I shouldn't say only. It can contain 64 bits. So you can have 2 32-bit objects. You could have 4 16-bit objects. You could have 2 16s and 1 32. So however you want to do that. This one we're having 116 and 132, so 48 bits. And then we have the actual object indexes themselves. So if I wanted to look up, what's 2200, what's 6064, those are CANopen object IDs. So if you go to the CANopen Programmer's Manual, you go to 2200, you see that those are the analog inputs, and then 6064 is the actual motor position. You can see right there. So, actually, so let me just go here to this. So here's where you'd see this. So it's integer 16 analog inputs, and it says that you can map it to a transient PDO. So that's good. It's read only. Access is read only. Units of millivolts. And this is the range of the value. It's in RAM. Okay. So that is that. Here's the subindexes that you would map, and then you initialize the PDO. So what's this right here? This is a COB ID, and I'm going to show you that in CANview. Each message sent over the CAN port has its own COB ID. So we're going to reference that. And different COB IDs have different priorities. You want to give, this is kind of the standard. So, yeah, I think that's 220 million or something. No, that's a hex number. So hex 200000001. And then if you had a second one, you would just say hex 200000002. One here represents the how many sync periods you want to wait before transmitting. So let's run an example, and we'll kind of see it in real time and better understand it. And then here is where we're assigning. So if I go up right here, this is where we assign to a slot. So as I said earlier, you have 8 of these, right? So we're going to use slot. We have the ability to use slots 2, 3, 5, 6, and 7 because 0, 1, and 4 are used by CMO. So you have the option of you have 5 different slots you can use. So let me go now to my example. And we'll go in here to the CAN address. It's 1, CANopen. I have some variables that I use. And then we have these TPDO constructors. So I'm going to use 2 TPDOs, and here's what I map inside of them. I'm going to log the actual motor position, the velocity, acceleration, the current. So I initialize the drive in an initialize button. You can only initialize the drive once. You cannot uninitialize a drive once it's been initialized. So in this example, we're going to here tell how you're going to initialize 2 TPDOs, and then we will initialize them here. This 1 means that they're sent every sync period. If this was 2, that means it would be sent every second sync period, 3 every third sync period, and so on. And then here I'm setting the sync period. So this is in milliseconds. So if I go to my GUI, this is how after you set the sync period, you can initialize the drive, and again, you can only initialize the drive once, so that's a one-time setting. Then we're going to initialize the 2 TPDOs. We're going to use slots 2 and 3 because they're available. And then, so let's run this, and I'm just going to show you what this looks like. So I haven't initialized the drive yet. And simultaneously, let me open up CANview. Well, something here we go. So there's no traffic because the drive hasn't been initialized yet. So let me go ahead and make this down to 1 millisecond. Initialize the drive. Here we go. So now we're seeing traffic. I've initialized the drive. I've set the sync period to be 1 millisecond, and I've initialized these PDOs. So as data is being transmitted and received. Now I'm going to use this timer here, and what this means is I can start logging. And now we see the data being updated. And I can go get a cup of coffee and come back, and when the timer elapsed time equals the use timer value, then it'll stop the log for me. And so if we look here, let me just stop this CANview just so we can look at the sync period. We see the sync period here. Sync message is being sent every millisecond because that's what we have right here, setting the sync period. And if we look, it is 1 millisecond in difference. And we see that every time the sync period is being transmitted, we're also transmitting these PDOs. So we have a lot of traffic on the network because we have a pretty fast update rate. If we were going to make this a little bit slower, that'd be fine. But okay, a minute's gone by, so it stopped it for us, and now we're going to close this, and I'll go to the project folder here, and in the folder, in the debug folder, we have the actual data exported to a CSV file. So we have the elapsed time, the objects that we mapped, I think it was position, velocity, and current, and another object. So yeah, we have all the data, and we should have, if we're updating every millisecond for 1 minute, that means that we should have 60,000 points. If you go down here, indeed we have 60,000. So yeah, you can do all sorts of cool things with data in Excel. So yeah, I hope this was helpful. Just to be clear, again, once you initialize the drive, you cannot go back and edit the PDOs. And so in here we have the first PDO, and then this is the second PDO. If you wanted to change this to say 32-bit integer, so like if I start up this this example again, and I want to change this to a CANopen object, I would pick an object from the CANopen dictionary. I would make sure that it's TPDO friendly, and this is an int 16. So I would want to map this 2201 in the 16 slot, not in the 32 slot. I mean, obviously you can go in the code and you can just rewrite, you can change that value. So in here, if you wanted to make this a 32 as well, you would just change this to 32, this pmap obj value. Similarly here, you can change this to a 16. You can also do an 8-bit integer or a 24-bit integer. So initialize the drive, start logging, stop logging. And yeah, this time we have a 50 millisecond update rate. So every 50 milliseconds, you'd get that data collected. And yeah, that's just a nice, cool application of how to use CMO to collect data. I hope this was helpful and kind of showed you kind of the functionality of CMO and some pretty cool features. So thank you, and hope this was helpful.